Now let's start exercise 3.1. Very first question is given here are some figures. 8 figures are given here and question is classify each of them on the basis of following. First is simple curve. How many simple curves are there we have to find out. First figure is a simple curve clearly. Second figure is a simple curve. Third is not a simple curve. Fourth is also not a simple curve because so many lines are intersecting each other. Now fifth is a simple curve. Okay, so fifth 1 2 5 and then 6, it is also a simple curve. 6. Okay, now seventh figure is also a simple curve. Starting and ending point are same and there is no intersection between those. So 1 2 5 6 and 7, all these 5 figures are simple curves. Now let's find out simple closed curves. Okay, so 1, same will be there, simple closed curve 1, then second figure, then fifth figure, sixth and 7. So same answer will be there for second part also. Now polygons, how many polygons are there? You know that polygons are the simple closed curve made up of line segments. This is a polygon. Second, yes, this is a polygon. This is not a polygon, it contains a curved part. This is also not a polygon because these lines are crossing each other. Okay, now fifth, it is not a polygon because there are curved part. This is also not a polygon because round shape is given here, means curved part is given here. It is also not a polygon because it is not completely made up of line segments, and this is clearly not a polygon. So polygons are 1 and 2. There are two figures which are polygons. Now D part is convex polygon. Convex polygons, I told you that polygons whose diagonals lie inside the figure. See, there are only two polygons here. In C part we have done, there are two polygons which are figure number 1 and figure number 2. Now out of these two, which one is convex? Second figure is a convex polygon because if I draw diagonals, the two diagonals will lie inside the figure. So figure number 2 is a convex polygon. Now concave polygon, this is a concave polygon because this diagonal will be outside the figure. So figure number 1 is concave polygon. Now sum number 2, how many diagonals does each of the following have? We have to find number of diagonals in the given figures. A convex quadrilateral. First part is convex quadrilateral, next part is a regular hexagon, and third part is a triangle. So this is a convex quadrilateral, this is a quadrilateral. So if I have already drawn the diagonals here, there are two diagonals here in the quadrilateral. Now second figure was a regular hexagon. So this is a regular hexagon. Regular hexagon means a hexagon in which all the sides are equal, and hexagon means a polygon containing 6 sides. So this is a polygon containing 6 sides. Okay, I have drawn all the diagonals here. I told you the method of drawing diagonals. So there can be 9 diagonals in a regular hexagon. Now triangle, we cannot draw any diagonal in the triangle. Triangle is the figure where it is a polygon, it is the only polygon where there is no diagonal. Okay, so if you are having any figure where the number of side is greater and we cannot draw it on a paper, how can you find out the number of diagonals? In that case we apply formula. The formula is n into n minus 3 upon 2. Whenever you are given that there is a polygon containing 10 sides or 6 sides or any number of sides, you can just apply this simple formula, n into n minus 3 upon 2, where n means number of sides. For example, this second part was a regular hexagon, means the number of sides were 6 here. If I apply this formula to find out number of diagonals, it will be 6 into 6 minus 3 upon 2. That means 6 into 6 minus 3 means 3 upon 2. 2 3s are 6, 3 3s are 9. See, without drawing any figure I can find out the number of diagonal. Okay, if you suppose you are given that find the number of diagonals of a polygon in which there are 10 sides. So you don't have to draw the diagonal, you don't have to just draw the polygon and then draw the diagonal. Just apply this simple formula and find the number of diagonals in any figure. Okay,